Hey guys, today I will solve these three derivatives. This is the part 2 of the proving famous limits and derivatives series. Okay, ignore this video 3. It's not necessary. My first part was supposed to be something, but I deleted it because I realized I was in a mess. Anyways, let's prove it. Okay, first we are going to prove the derivative of ln x. Yes, okay. We are going to use the definition of derivative for this one, so it will be limit as h tends to 0 of ln of x plus h minus ln x over h. Okay, by the loss of logarithm it will be limit as h tends to 0 of ln of x plus h by by x, my bad, over h. So this will be limit as h tends to 0 of ln, okay, when we separate this it will be 1 plus h over x raised to h. Okay, in the previous video we proved that limit as x tends to 0 of ln 1 plus x over x is 1. We proved this previous video. This looks an awful lot similar like this. Instead, here it is h over x and here it is h. What we will do? We will divide by x and you compensate by multiplying by x. Okay, so this will be, okay, so we can write this x as limit, wait, I'll write it right now, 1 over x times ln 1 plus h over x raised to, by, why do I say raised to, okay, h over by x. Okay, h is not in this term, so basically 1 over x is a constant with respect to h, so you can take 1 over x out and it will be limit as h tends to 0 of ln 1 plus h over x raised to, why am I saying raised to every time? It is by h by x. Okay, well, this is one. This was when we proved this, yes, last video, and this is the same thing as this, so this is equal to 1. Therefore d by dx of ln x is 1 by x. Proved. Now we will prove the famous derivative d by dx of e to the x, which is e to the x. Let's prove it again by the first principle or the definition of derivatives. This is the standard stuff, I don't need to explain anything over here. This is just the definition of derivative. It will be limit as tends to 0 of e to the x, because of law of exponents, so it will be, this will be e to the x times e to the h minus e to the x. We can take e to the x common, so it will be, e to the x into e to the h minus 1 over h. Okay, since this term is a constant with respect to h, it will be, we can take e to the x outside. It will be limit as h tends to 0 of e to the h minus 1 and e to the h minus 1 over h. Well, we proved this last video that this was equal to 1, so it will be e to the x times 1 equal to e to the x. So derivative of e to the x is e to the x. Proved. Well, for the last limit, not last limit, last derivative. Okay, so d by dx of a to the x is a to the x ln a. where a is a constant. Same thing we'll do. So it will be, we are going to use the first principle again, so it will be limit as h tends to 0 of a to the x plus h minus a to the x over my bad is h. So we can again take a to the x common. It will be a to the h minus 1 over h. Well, again this is a constant with respect to h, so it will be, we can take a to the x outside. And we proved that last video that this is ln a, so it will be a to the x times ln a. So therefore d by dx of a to the x is a to the x ln a. Proved. Thank you guys for watching this video. Please subscribe and view this video and share it and like it, all the regular stuff which every YouTuber asks you to do. And next part we will prove the power rule. Yeah, we'll prove the power rule. Bye bye.